guest is Peter Sutch. He will be talking about BI solutions and how to use data to deliver insights to business. Peter is an accomplished BI engineer at Amazon and is leading analytics and data engineer. As a graduate of UCLA and USC, he is skilled at doing both sides of California. He's skilled in transforming complex data into strategic insights with roles including analytics, data engineer. Peter has architectured robust data systems. Currently still as a BI engineer at Amazon, he crafts intuitive visualizations powering informed decisions. A passionate learner, he extends expertise through workshops, publications, to make his influence in the data community. Again, going to welcoming Peter Sutch.
Introduce me more than I know myself. So I know this is a last session for the day. You guys get bored of it, just bear with me for another 40 minutes. And, I think you guys can get a lot out of it. So here's a little bit background of myself. So by day, I am a BI engineer. I'm working at Amazon. Specifically, I'm working in the advertising department, and our team is a lot of moderation. So to kind of automate the moderation process, and also do a lot of the data analysis to ensure the advertising had the best of the customer. So by night, I am also teaching in one of the boot camps hosted by the actually back in the days I was a student for that boot camp. After I graduated, they decided to hire me as an instructor. So a little bit of my education, I got my bachelor's degree from UCLA back in the days, and then I graduated from the USC from a bachelor's degree. So that way I don't get hate by both. So here's the agenda for today. First of all, I'm going to walk you through a brief history of the evolution of the business intelligence. To see how, nowadays, a lot of people refer to the business intelligence. Like, why does it come from? How does it come from? The modern context of the business intelligence. And then I'm going to talk about how to, in order to deliver a successful BI solution, what kind of the BI framework should you need, right? Because you can't just randomly deliver now, like here's data until that solution. No, that's not the case, right? Because you actually take picture of the BI framework. And now I'm going to talk about dimensional modeling, which is one of the optimizing techniques. And the data pipeline is a process of how you're going to deliver the raw data to the end customer, right? You're going to be using a data pipeline to. And then the final one, talk about the future of the business intelligence, right? Like given that nowadays a lot of technology, you can do a lot of the automation, but how does the business intelligence future looks like? Okay, so the evolution of the business intelligence, typically can be seen in two stages. So first is the pre-digital stage, and next is the kind of the digital revolution stage. So during the pre-digital time, the business intelligence term was actually introduced by a guy called Richard Millen Gibbons in around 1865. So it took me a while. I was gonna find a picture of that guy, but they're too old. I don't know. So yeah, but he introduced the term business intelligence, right? And in one of his journals, he kind of described how a banker kind of successfully positioned himself ahead of the game, kind of collecting and analyzing the data in order to make more informed decision, rather than just rely on the instinct. So that is the first case where people actually think about I'm not going to rely on my instinct, but I'm going to collect the information and sometimes newspaper, etc. And then comes to the digital revolution of the 1950s, where a lot of the digital revolution comes to advancement computing, right? And because of that, there are two big milestones happens for BI. So the first one is that IBM invented the world's first hard disk with 5 MB storage. So which actually enables the business to store the data into it, and then you can access the data faster than ever before. And meanwhile, the IBM computer scientist also described the potential use of the BI in one of his papers. So he envisioned that there could be a system in the future, which allows your business leaders to directly, extract insights from the data. Like you don't really need to do a lot of data analysis, but the system will automatically draw those insights for you. So because of those two milestones, so IBM again. So in 1970s, they developed the IMS, right, which is the information management system. So which was the world's first hierarchical the database. So because of that, which actually the IMS was enabled to business to store a large volumes of data. That's actually a hierarchical system. So because of that, there were two products like with it. One is the RDBMS, which is the relational database management system, and also the structured query language, which is SQL. Right? Everybody uses SQL in the data field. So because of those two products, which makes it much easier for business to accessing and analyzing data, right? Because it not just provides us a tool, but it also provides us as a structure and a more standardized way to accessing and analyzing the data. And then later 1980s to 1990s, the concept of the support decision system came out. So the DSS was introduced and was designed for the business leaders to kind of do some of the data analysis by data modeling or data simulations in order to make more informed decision. So because of that, actually in later 1990s, a lot of the BI applications was kind of developed, like such as MicroStrategy or Lawson. And actually nowadays, a lot of the companies are still using those type of systems, right? So we refer those as some of the legacy systems. So here are the examples of those systems, right? Typically, like the companies using that, like Synchro, less people use Synchro right now, but Salesforce for sure, SAP or Microsoft Dynamics. So a lot of companies using those type of systems, like they use that to kind of data to store the data, to kind of input the voices, or they can run the exporting the data and then can do further analysis with it. So typically there would be a database. Okay, I got it. Yeah, so I was gonna go into one by one, but yes. Yeah, okay. So typically there will be a database, right? Like a kind of stored in those type of applications, right? Normally the data was stored with the transactional modeling. So here's a kind of an example of how those data were stored in the backend. So as you can see, kind of those tables are kind of related to each other, with like a one-to-one or one-to-many or many-to-many relationships, right? And also there will be a designated group of DBA who is maintaining those type of data, and they're responsible for like updating the data or inserting the data or deleting the data if anything goes wrong. So it's a pretty kind of classical way to kind of do those type of data management. So for those people, like for example, if they need the data, they can just simply write a query to getting those data out of there, and because they know how to write query, they understand the kind of table, the relationships between the different tables. But have you guys thought about they are not the one of the end user for those data, right? Like they don't really need those data in order to make more decisions. So business people are actually the end user of those data, right? They're gonna need those data in order to make more informed decision, right? Based on, for example, the data driven or the data informed decision. So how are they gonna do that with those type of I would say the legacy applications? So they do it through the classical reporting. So here's a kind of an example of how those BI applications can generate a report, right? So like they can typically just drag and draw different fields into the report and then click generate, and then it will generate a report for you. And then also they can kind of play around with the filter to the right time and filter to the right business definition. And then most of the times, probably they're gonna exporting those data and then continue work out of it in the Excel spreadsheet, right, by doing a different pivot table or by building different graphs, right, which is good. So this is a kind of very classical way of approaching those type of reporting, right? However, there are some problems with those types of decision reporting. The first one, slow extraction, right? So think about it, with those type of legacy system, you have a very little kind of optimization going on in the backend database, right? So, and also if you do, like for example, if you run 5 years or 10 years of data, it's gonna take forever to run, especially with those type of transactional modeling, which you're gonna report every single row, every single transaction in the table. It's gonna take you forever to execute. Second, there's no room for automation, right? Think of, because you are doing all those by hand, you're gonna log into the application, and you're gonna drag and drop different different fields to the reports, and then you're gonna play around with the filter. Like there's really little rooms to automate this the process, right? The third is a no customization. So like think about it, if you're gonna need those data and you're gonna create certain KPIs you want to present to the leadership, you want to put some logos into it, or you want to make some the beautiful color, right, which matches your color theme. You simply cannot do that. You have to export it and play around in Excel. And also no sharing. So with those type of the application, you want to give another person an access. We probably have to buy additional licensing, right, which will be additional cost, right? So probably the only way I can think of to share those type of data is through the manual sharing. So, export the data into the Excel, probably, and send it out via email. Do that consistently, right? Also human mistakes, right? Because there's a lot of the manual process going on, especially in exporting those data into the Excel, and then you're gonna do further calculations out of it. Just cannot avoid there will be a human mistake, right? Human making mistakes all the time. Okay. Okay. And then the business intelligence framework comes into this game as kind of a lifesaver for those type of the classical reporting. So I think this is in general how a BI framework should look like in order to deliver a kind of a successful BI solution. So in order to create a BI framework, the first thing you need is people. So people in here refers as a technical people or non-technical people, right? Like a technical people can be the data analyst or a business analyst or a BI engineer. So they are the one who is creating those reports. Like they are the one who kind of automate the entire process to making sure that you're coming from the raw data to the data which is usable by the end user. So they are the one who needs to kind of creating the process. And also non-technical people are the people who is like supporting your business. They are kind of the end user of the data. Like they are the one who will need the data in order to make the business decision. The second pillar is the process. So you need a kind of well-designed process to kind of teach you how to use the data. Like for example, you can't really just throw the data to the business and say, hey, here's data. You can make the decision. Like you cannot do that. So you have to create a process or like a workflow to kind of work with them how to define the metrics in the first place, and then how you're gonna use the data. Like is there, what is the exception of the data, or is there a yes, right.
Good day, folks. It happens.
And so you can't just throw the data to them. You have to design this type of process to help them to understand this data, right? To kind of also help them to teach them how to use the data to make more informed decisions, right? So that's the second pillar. The third pillar will be the technology. So the technology here, right now there are a lot of the kind of very most advanced state-of-the-art technology here, but you don't really need the kind of state-of-the-art technology. However, the technology is able to handle those type of data processing, be able to do all those data transformation or data loading, or creating different the dashboard or reports out of it. So the technology you have needs to be able to handle a different request that your business needs. So on top of that three pillars, there's one important thing I like to mention. Data, right? So you can't really create a successful BI solution without the structured data, right? So for example, think about all your data. Let's say all your data is in the different Excel spreadsheet, just in the shared drive. It is really no way for you to automate that, right? So you have to create a structured database, whether it's a relational database or it's NoSQL. Right? So you need to think about how you're gonna kind of transfer those the data to a kind of a structured database. So all those the aspects that makes up a successful BI solutions, so that way you can deliver a successful, create a successful business intelligence solution to your end user. So now you know how to kind of create the BI framework, but there's one thing I like to mention is that you cannot deliver a successful BI solution without being closer to an end user. Right. So think about it. You guys are the one who creating those reports, who running those data. So you need to specifically that you don't want to wait for the questions. So you don't want to be reactive. You want to be more proactive. Talking to a business people to understand their needs in order to create more successful metrics in order to measure their product or the business. So you need to help them to identify what they want, because in most of the business people's mind that they have a little background to the data, like they don't know what data is available to you, or how are they gonna translate the business, into sense of the data. So as a data person, you will need to help them to identify what they want, be able to tell them, hey, you want to measure these metrics, you want to measure this business, this is the metrics you want. And also, you want to be closer to any business decisions, right? Because you won't be able to understand the business without being closer to the business. And specifically, you want this is what I think is you need to think yourself as a product manager. So you don't need to kind of innovate a new product as what the typical product manager do, but you will need to understand your business and understand your product just as much as a product manager. Right, so that way, you can kind of create a successful metrics to kind of support the end user, and then you can think about how you can use the data to improve the products or the business. Okay, so now you know how to create a successful BI framework, and you know how to work closely with your end user. So there's one thing you want to do is you will need to create a kind of a BI technical environment, right? So one of the technical environment is what we call as a data warehouse, right? So that's kind of answered the question of how BI can effectively query the data for reporting or for dashboarding or for ETL, right? The answer is simple, just building a data warehouse. So maybe a lot of people, especially for most of the traditional industry, where they don't have the business intelligence implemented because a lot of their system are assisting the legacy system, like migrating from the legacy system to a kind of a new state of art, the technology will be a huge cost, which is understandable, right? But so they may ask, like, why we need a data warehouse? Like, why can't we just put everything into our legacy system, then we can just directly run reports on it, right? Here's the why. I'm going to pick a couple the points to talk about. The first one is the consistency, right? Because every time when you have the new business data comes in, you don't want to kind of put your business data into different places. Like especially think about it, you're gonna using a different, for example, Excel reports. If you store all the data into Excel reports and put them in different places, it's just making very hard to kind of, if you wanted to do a consolidated analysis, you're gonna combine all the data together to do that. So it's just very tough to when you want to access those data later on. Right? And also the immutable environment, because once you store the data into a data warehouse, like nobody can change it, right? Besides the DBA, normally those people will not change the data if there's a need. So nobody can change it, unlike putting the data in other place. People can accidentally mess up with it and they just lost everything, right? And then some of the like a single source of truth, where if you store everything into a data warehouse, everything you pull out of the data warehouse will be in that table. Like as long as you are writing the right query, as long as you follow the business decision of how to define those metrics, like your number will never change. Okay, so now you kind of know how to create the successful how to create a data warehouse. Once you have a data warehouse, there's a lot of things you need to do to kind of optimize the data warehouse in order to kind of query the data effectively. So one of the techniques is what we call a dimensional modeling. So first of all, what is a dimensional model? So by Rob Kimball, so dimensional modeling is a design technique for database intended to support end users query in a data warehouse. So Rob Kimball is a kind of author in the business intelligence and data warehouse, and he's kind of the creator of the dimensional modeling. So in one of his philosophy that he thinks the data warehouse needs to be understandable and fast. So I kind of highlight two words in here, right? One is understandable and one is fast. So you can't just building a data warehouse where you throw different data in there and creating a bunch of tables that nobody understands it, right? It just kind of defeats the purpose of optimizing it, right? And also it needs to be fast because once you throw the data into the data warehouse, and there will be a lot of people to query those data in order to kind of do the reporting. You don't want to kind of like writing a query to query from the data warehouse that takes forever to execute. So two things, dimensional modeling. Also, two things of the data warehouse is one is understandable and one is fast. So here's the star schema, right? So I think most of you guys already know what the star schema is. So which is one of the architecture in the dimensional model is how you're gonna design the tables that you store into the data warehouse. So there are two aspects. There are two attributes in the star schema, and one is the dimension, and one is the fact. Okay. So the dimension is defined as any categorical information which is separated by further categories, right? So for example, you can see the dimension, there are 4 dimension tables in here. So we have a product dimension, we have a customer dimension, a time dimension, and a promotion dimension. And those categories are all categorical information. So that's how we define the dimensions in the star schema. Product, customer, the promotion. Okay. So the fact. So another attributes of the star schema is the fact, right? So the fact is defined as a metrics that can be measured under a model definition. So what does that mean is you can see the revenue, the units sold. Those are kind of the numerical value, so which you can define as a fact. So that's how we kind of separate those two attributes. Unit price, the revenue, and the revenue. Kind of calculate the unit price by using the units divided by the units sold. So that's another factor you can add to the table. Everyone just kind of like. Okay. So the couple key points in here in the star schema. Which is in the dimension table. So the dimension table can only related to the fact table. So this is unlike the OLTP design, which you have a different transactional. The data was stored in the transaction modeling, where all the tables are connected to each other, right? Like you can write a query to connect one table to another one. You can write another join function to connect another one. So you can connect kind of all the tables together. But in the star schema, the dimension table are only directly related to the fact table only. Like the dimension table in here cannot relate to each other. The second thing is that dimension tables are denormalized. So denormalized means there's no like a duplicate records here. So for example, the product dimension, you will not see a product ID, which the product here is the kind of dimension. You will not see a same product ID, have a duplicated role. So that's kind of effectively more efficient in storage. And third thing, you have a multiple granularity in one dimension table. It's called the dimension attributes. So taking an example of the promotion dimension, you see you have a promotion ID, you have a promotion name, and also you have the ad type, the coupon type, which is also a categorical variable, right? But that's not a dimension, but it's more of the dimension granularity. It's more of the dimension attributes. So now you know how to do a optimization in the data warehouse, and the next thing you want to do is you want to execute the data, right? You want to build up the metrics. So one of the techniques you can do is the data pipeline, right? So first of all, like what is the data pipeline, right? So I like to kind of use an analogy here to this is an analogy I learned what is the data pipeline. So I think it's pretty for you guys to understand the data pipeline. So have you guys ever thought about how does the water you drink every day comes from? Like like how can you like drink the water every day, right? So the water in here will typically come from a lake or ocean or come from river, right? So you probably most of the times you're not gonna drink the water directly from those sources, right? Because you want to kind of transfer those water in a way that is safe for us to use. So the way you do that is you're gonna introduce a lot of a pipeline, the water pipeline, to transfer the water from the source to a treatment plant where you're gonna kind of purify it, you're gonna clean up the water a little bit, and it's safe for us to use. And then once the water is safe, you're gonna create more pipeline to transition to the kind of the end customer, like for people to, for example, you can use those clean water, you can drink it, you can clean up, you can do laundry, or you can do the agriculture, right? So this is a kind of a process of water pipeline. So in terms of data pipeline, if you just think from a data perspective, this is how a data pipeline looks like. So instead of the lake, we can think of this as a data lake, and also we can think ocean as some of the legacy systems, legacy applications, and river we can think of streaming data. Right. So most of the times you cannot use the data from those sources directly because it's not clean and it's not easy to use. Right. So you want to transition right the data from the source into a way that is understandable and can be used by our end user. So we can do that by building a data pipeline. So some of the data pipeline skills are the like ETL, or you guys are familiar with that, which is extract, transform, and load, and DB as a data virtualization and data replication is DR. So all these processes is what we call a data pipeline. So we want to transfer those data in a way that is understandable for use. So we're going to do that by building a different pipeline. And then we're going to process those pipelines a little bit to kind of clean. And then we're going to use more data pipeline to transition to the end user. So they can do a dashboard, and you can do a reports, or they can even do the alert system out of it, right? To making sure the data is is correct. So we want to be alert if there's something goes wrong. So here's the real example of how data pipeline looks like. So first of all, you're gonna have source from different places, like for example, legacy system, or ERP or CRM, or you can have a data in the text file, or most of the CSV file, or you can even store data in the Amazon S3 bucket, right? So the data is in everywhere. So what you need to do is you want to extract the data from the sources, and then you're gonna put into a staging process where you're gonna do some of the data cleaning, right? So some of the process you can take is you can clean up the data, you want to transform the data, right? And then you want to validate the data to making sure the transformation is accurate, right? And then you want to do some data aggregation because most of the case, those raw data has a lot of rows because most of the times you don't want to report at the very lowest level. You want to report on the aggregate level for business. And then once you aggregate the data, the last step is you want to load the data into a data warehouse, right? That's the case why we need the data warehouse in the first place. But once you load the data into a data warehouse, and the parts in here is what we call a data marts. So each data mart serves a different purpose, for different organizations within a company. Like for example, you can have a data mart for say HR. You can have a different another data mart, so let's say for supply chain, right? You can have a different data mart for marketing, etc. So different data marts serves as a different purpose in the organization. So that way, you want to share the data across the company. Some of the data are pretty sensitive, only certain people can see it. So that's why you want to build a different data marts to serve as a different organization within a company. So the entire workflow is what we call the ETL, right? So you want to extract the data, and then you want to transform the data, and then load the data into a data warehouse. So at the end, once the data is clean, stored in a data mart, and then you can use those data to build up a different BI results. So some of the BI results are like you can do some of the OLAP analysis, right? You can data mining or do some exploratory data analysis. And also you can build a dashboard on that. You can build a different tab. For example, there are different ad hoc requests. You can just building a reports, and then you can also do some alerts on it. So here's the real example of how the Amazon AWS is doing the data, the transformation. So here we have two parts, right? One, we have a data on premises, meaning the data that's stored in your local company. Like for example, if a company wants to leveraging AWS cloud system to kind of transform their data, but the data they have is not on cloud yet, but it's on the local. Like they will have their own data center which stores all different data, right? So that's the data on premises. And the second part is the AWS cloud environment. So for example, if they subscribe to the AWS cloud services and they transfer those data from the locally to the AWS cloud, that's where all the transformation happens. So for example, you can have the data from the server and then kind of upload it to the cloud, and then for example, first you can just put the data into S3 bucket, and then let's say the data is, is big data. There's a lot of records in there, and you can use the Amazon EMR, which is a elastic MapReduce. It's used to deal with large volume of data. Once it's using the EMR ETL cluster, you can again put it into the Amazon S3 bucket for more kind of for records, right? You don't want to lose it, and then at the end you can kind of load to Amazon Redshift, which is a Amazon SQL database. Like a lot of the BI, a lot of the data engineers directly query the data from the Amazon Redshift. Okay, so starting from here, that's where we're going to put up the different BI solutions to the end customer. Like we can do the BI dashboard analytics, or we can run some ad hoc query other things. So the business intelligence is really like an iceberg, right? So what people see is actually really the tip of the iceberg. So here's what people see. So they think BI is doing the QuickSight dashboard, or they're doing a Tableau dashboard, or Power BI dashboard, right? They're doing a dashboard, or they're running a different Excel reports. For example, running a lot of the ad hoc query, like just building up different reports for different business needs. However, that's really just the tip of the iceberg. What really happens within the BI, so we have a technical aspect of the BI, which we have ETL, ELT, data cleaning, data modeling, data loading, query optimization, right? Because as you are building a lot of the different data pipeline, you want to see about how you're going to optimize your query, right? Because you can't just running a back query, which is going to take forever to execute. It's the purpose of automating, right? And also scheduling as alerts and then scheduling. So scheduling, as you're building a different data pipeline, some of the data pipeline might run in a sequential, right? A sequential order. For example, you can execute the next one until the previous one is finished. And also some of the pipelines running in parallel, right? So you want to set up those type of the schedule in order to kind of optimize all the execution time. Also NoSQL, because not everything is stored in a relational database, and also some of the data was stored in the NoSQL database, right? If there's a two database, how are you gonna kind of collaborate with those two different databases together in order to kind of pulling all the data together at the end? And also think about security, because you don't want to share all your data, with everyone. So just think about how you're gonna create the security to kind of prevent the people from seeing it. And also some of the data workflow. So that is the technical aspect of being the BI person. But also, there will be some non-technical aspects. So, for example, first you have to understand the business knowledge, right? Because you can't really create a successful BI solution without understanding the business, right? Because your guys are the one who are creating the metrics in order to help the business to understand how their business is doing, how their products are performing, right? So you really cannot do that without understanding the business. And also communication, right? So because you're gonna need to work with the business people a lot, right? Trying to understand their needs. You can't really work with them if you don't have a great communication skills. So that's very important also. The third one, critical thinking, right? Because you're gonna create the different metrics, you have to innovate, right? Because most of the times when the business people have a request, they're not gonna tell you, hey, you need these metrics, right? They're not gonna say that directly. They're just gonna state out the business problem, and then you will need to actually help them to identify, like thinking from a data perspective, what kind of metrics should I create in order to solve your business problem, right? So that part you want to have some certain types of proficiency skills in order to translate the business questions into a data related. Okay. So the future of BI. Here's a graph of like the number of the volume of data information that's created, captured, copied, and consumed by the internet over the years. So as you can see, from like 2020 or to 2025, the amount of data is kind of increased by over 20%, right? So no doubt, BI will be one of the coolest job in the next 5 or 10 years if you're doing it correctly. So because you will need some people, like business will need some BI to kind of do a lot of downstream analysis because they're gonna have a lot of data, even though they're gonna have a bunch of, for example, a data scientist who is creating a model and then they're gonna give you a results, but you will still need the BI, the person who understands the data, do those type of analysis to see how that, for example, the machine learning model helps the business, that it's effective or it's not. So another thing that the future of the business intelligence is that in the future, this is what some of those bullet points is what I'm struggling nowadays today. And the first one is I hope there will be more self-service business intelligence, right? So for those of you who already work professionally in the data field, how many of you guys are being annoyed by the number of the ad hoc requests you receive every day? Right. So how many of you guys want to create kind of a self-service business intelligence? So every time when the kind of business people ask you for the report, they can just go kind of query by themselves without understanding how to write query, without understanding the kind of relationships between the people. Right? So that would be cool, right? Because right now some of those can be kind of accomplished by building a different dashboard, but because the business requests varies a lot, right? Building a dashboard cannot satisfy all different types of requests. Probably can cover partial, but it cannot cover all of them. So I hope that the self-service business intelligence, and I think right now there is already a trend, right? For example, in Amazon, we're building a kind of a service of business intelligence kind of self-service tool. I forgot the name, but I think that there is a tool for all of the business people. They can just directly get the data from those applications without just asking us to run those simple queries for them. So second thing is a real-time business intelligence, right? So right now, a lot of the pipeline that we are building right now, for example, some pipeline is refreshed weekly or some pipeline is refreshed daily. But if there is something urgent happens, you will need some real-time business intelligence, right? For example, if you have a certain product that is actually fails, and you want it to be alert automatically, right? But right now, because of some data pipeline is not refreshing on time, and also right now a lot of one is not really worth it to refresh on time, but it's still a good idea if you have a more and more real-time business intelligence. That way you can get alerts right away. For example, if there's a sudden increase of the return rate, right, for certain products, you probably want to take a look right away, right? Instead of you want to wait for like a 10% or 20% of return rate on certain product, that would be a loss. The third thing is the headless BI. So in here, I'm just gonna briefly mention about what is headless BI for those who don't understand what that is, because I can go entire session just to talk about the headless BI. So for those of you who work with data, or for those of you who are the end customer of the data, how many of you guys got annoyed by different types of different number in reporting? For example, if you receive a KPI today, one of the metrics is, let's say, 2%. Next day, when you receive the exactly same data, but just because the data is refreshed, it becomes 2.5%. Right? So there's a lot of cases something like this happening. It's because the different people running those reports, they're gonna using a different types of logic to building up those metrics. So the headless BI is kind of solve that issue by creating another layers between the data warehousing and the BI applications. So in our original approach of the BI is you're gonna have a data warehouse in one place, and then you're gonna build up the connection to the BI applications, right? So that is the original, like the current way we're doing right now. Like the people can writing a query or building up a dashboard or building up a data pipeline directly from the data warehouse. So the headless BI, on the other hand, is by adding another layers between the data warehouse and the BI applications. So another layers we can refer as kind of a headless layer or the semantic layer, which in that layer, you're gonna have a lot of the metrics is defined in the first place, right? For example, if you wanted to calculate, let's say, a rejection rate, how are you gonna calculate the rejection rate? Like who is on the numerator, who is on the denominator, right? You have all those defined in the first place. So every time when you execute the same metrics, you will just go through the semantic layer first, instead of going to the data warehouse first. So that way, the number will never be wrong if you are using the exactly same semantic layer to kind of generate the report. Because this is something I suffers a lot, is that every time when we do a kind of the KPI reporting, and let's say quarter one, I send out the reports to our business people, and then in quarter two, there are certain business definition change, and then in some of the data in Q1 got changed. And then I get all the questions, why they change? Like, I don't know. I have to go through all those data pipeline, right, to find out, what's wrong with it. That was spending the entire day just to go through all the data pipeline to find out what actually goes wrong, right? But sometimes it's not really wrong, but sometimes it's really just we change the business definition. And not everyone is in line with those type of changes. So that's a lot of the time, spend it with those type of investigation and see what's possible. So the headless BI for sure will solve these type of problems. And, that will be it for today. Thank you, everyone.
So now we have 10 minutes left for questions. So that's what we got. One already.
So we designed a different process where specifically to identify those samples. We have a document each step of those transformations, and every step is generating a separate report. So, for example, if you get a number, you can look at the first variables.
One of the things that's like business stakeholders, right? So we know what the problem is. And as a data analyst or as a scientist, right? Like we need to ask the question, like what is the problem? It's like I've never been in the field, but I want to know, like, if you have ever your stakeholders don't know exactly what the problem is, they just want to solve something.
Yeah, so that's exactly something I fix this every day because our business people don't really understand what they're trying to do, but they only have a business case in their mind. So first things I always ask them is, what question are you trying to solve? So you need to understand from their perspective, like what exactly is something they're trying to solve. So once you identify that problem, you can go back to from data perspective to see what kind of data we have right now, and then how we can using those data to create different metrics to solve that problem.
Just one more question. Like, is there any thank you. So like to that's architecture, like, do you also face that scenario after like having one, like when you go like, okay, maybe this is the problem, we need to solve. Ask the questions and then play the data and then did the data analysis and then the students, it's not exactly once, like, is that, does that happen?
Yeah. Sounds like you're very experienced. Yeah. First of all, it definitely sounds very experienced because those are the type of question the BI also data analysis every day, right? Because our job is really to help the business people to using the data to measure, for example, success of the business. Like for example, if they're launching a new product, we want to use data to see, this product is successful versus unsuccessful. So that is the whole point of why they actually want us to show them the data, right? So again, the first thing is really to understand what they're coming from. So if this is something, you say they ask you the business question and you ask back, and then you understand what they're looking for, you deliver something to them, and then if sometimes the number doesn't show it that way, it's not because your approach is incorrect. And sometimes the number doesn't show that way. Like for example, you want to see the product is successful with number, but the actual number is showing it's not very successful. So from that perspective, you might want to go to a different approach to think about the other measures that you can.
Thank you for the wonderful talk. Just some question around the enterprise-based elements that are coming up, or like just function-specific elements with respect to analytics and just using your tables and dashes much quicker. How do you see them working, whether in collaboration with current BI users or like especially some of the use cases such as self-service BI that you mentioned? Do you see them replacing that use case?
I do see some of those, especially with nowadays a lot of AI and also some of the headless BI I talk about. It's going to take a lot of take away a lot of our time, right? Like I don't need to spend time on those type of ad hoc anymore. Actually, I think that's a good thing. So because I really don't want to spend a lot of time to running the queries for people to pull the data for them. So that is not what I want to do. I think as a successful BI, you need to innovate. So because again, coming from the business perspective, the business people don't really have a deep knowledge on the data, right? But the good BI, like how a successful BI solution looks like, is you want to kind of help them to innovate the metrics. You want to help them to build up the metrics. Those are type of things I think AI cannot do right now. So that is, I think that's where the real value of the BI comes from. Instead of data for them with dashboard, that's not really a real value of BI. Although a lot of BI are doing that, but I think as the development of the AI, a lot of those type of what you replace as professional, you want to keep learning and also be able to adapt to those changes and also innovate those type of the new metrics in order to help the business.
Just a small follow-up on that. So does that innovation in BI also includes defining new metrics and new data collection processes from the scratch as well?
Yep. Okay. Yeah, and also I think another thing I like to add is that, as a BI, you don't want to just focus on the development. You also want to apply some of the skills, because you are the one who can build up those different data warehouse, transfer the data into a different place. That's the skill also comes into place, because you don't want to rely everything to your data engineers in the team. You want to be able to do it by yourself sometimes, so that way you can get more control of the project. Worse.
Hello. So I know most of you here are students. So what advice would you give for somebody that's in their master's program to get a job like this?
So first of all, I think it's almost time. So So I'll give you a brief introduction, but feel free to connect with me after the session. So one thing I would give to the current students to get a step into the BI job is you wanted to be able to practice your the soft skills, because that is something you will not have too much of the opportunity in school. School mostly job, you learn Python, you learn SQL, all those type of data processing techniques. It's good you have that, but one thing you will also want to practice soft skills and your communication skills, right? This is something that BI is actually that's where it makes a successful BI. That's the difference between a successful BI and a normal BI. So you want to be able to communicate to people, be able to ask what their needs, right? Like if they have a question here, like if they ask you a question, asking back, like if asking one clarification question, you really identify what do they want in order to step into those type of things. Right? Especially for other jobs like data scientist, data building, data modeling, right? But not too much into business, but BI. I would say BI is really about a hybrid work. About 50% of the technique and 50% of business. So that 50% of business, that's going to require you a lot of the communication skills and be able to communicate to the stakeholders.
Also, data kind of language, that's the first step of that, the soft skills. So congrats to all you guys doing that. So continue to come out to data kind of LA, join the community of your technical community, anything like that to be more involved out. You can't focus on the soft skills. Again, Peter, thank you for your time. Hope you come back again next year and talk to us. And if you guys are all out there soon, you might be able to come and take the speaker in the future after the master's program. So, you guys come to kind of late 2023. See you next year.